Let us examine a normal random variable by drawing a normal distribution. More than 99% of observations in a normal distribution happens between average -3 and average +3 standard deviation. So if I want to draw a curve for normal distribution, I should cut this distance in small pieces and for each piece draw the curve. I'll come here and define something called increment, 6 times standard deviation. And then because I'm going to draw this, I want to have, say, 1000 points divided by 999 equal to 100 minus 3 standard deviations. That is my starting point. Now I should go ahead and add this starting value to my increment and lock the increment because we are going to copy down. Now I should copy this down until I reach 175. It may take time. So I delete this. I insert a column here. Go here and type 1. Go to the corner, right click, come down, go up, series. Row? No, columns. Start from 1, go to 1000. Okay. Now I have from 1 to 1000, I come here equal to the starting point plus increment F4, enter. Now I copy it down and I'm sure 175. Now I can come here and I can delete this. Equal to norm distribution. What x? I want to draw the height of the curve for each of these points. So I start from the first point. What is your average? I go here, click, and lock it. What is your standard deviation? Click and lock it. The last item is, do you want to enter 0 or 1? 1 we enter to compute probabilities and we will work with it a lot, but for the time being I'm just going to draw the curve. I want to find the height of the curve. Therefore, to find the height of the curve, I enter 0. When I want to compute probability, I enter 1. 0, enter. And then click. 0, let me add 1 decimal point to it, or even. Okay, now we have these numbers. I mark them, insert, go to recommended charts, all charts. I click on area, and that is what I want. I cut it, and I go up, and I paste it here. If you want to make it just exactly within some cells, you can do Alt and then bring this here exactly to the cells, and you can also go here and click on it, Alt, and bring it down. It snaps to the cell. I don't like this color, Control 1. I give it the color that I like better. These numbers 1, 2, 3, 4, 36 do not have any meaning. I select the data, go to the horizontal category, edit, and then click on these points and replace those points with these points. Okay. Now I have the exact x's, but I really don't need that many decimal points. So I go here, numbers, and I change the digits after decimal points to 0. Now the curve looks better. Delete whatever we don't need. This title, I don't think I need it. We know that this is a normal distribution. I don't think we need this. And I don't think I need this horizontal line. So now I have a neat graph, a very good shape, and that is a part of what we call it visualization. When we want to explain something to our bosses, if we put it in a graphical representation, maybe they understand it better. Now suppose I want to draw this curve for values which are less than or equal to 120, equal to if this x is less than or equal to this value, and I like it because I'm going to copy it down and I want it to stay over there at 120, then plot it. But if it is not less than or equal to that, then nothing. Enter, click. Decimal points. I copy this, I click on this, and I paste it. Now this is the probability of x being less than or equal to 120. I like to change this color to something else, and that's it. Now we have a normal distribution which shows probability of x being less than or equal to something. I can go here, equal to rand between, for example, 30 and 170. Now, as that number changes, this graph also changes. So now we can compute probability of x being less than or equal to something. And I can go here and I change this one to 75. And I change this one, for example, to 20. That is still valid probability of my x value being less than or equal to something. So now we have created a normal table. You were using a standard normal table, but here is a general normal table, and it is always at our disposal. This normal distribution, for example, could be the demand for our product. Suppose the demand for our product has average of 100 and standard deviation of 25. Or it can be, for example, cost of a product, an average of 100 and a standard deviation of 25. And we want to know what is the probability of our cost being less than or equal to 120. To compute the probability, we want to compute this area. That is the probability of x being less than or equal to 120. Equal to the same thing as we did before. Norm distribution, NormDist, x 120, average 100. And like it if in case we want to copy it down, standard deviation 25, comma, now instead of 0, we enter 1 and it will give us probability. Now let me go here, equal to quotation probability of quotation and left this one, comma, 2. Probability of x less than or equal to, I'll go, and 120. Probability of x less than or equal to 120, I can change this one to 130, and that is also changed to 130. And space, quotation space, equal space quotation, and this one, but because it has a lot of decimal points, we'll go here and round to chart design, add chart element, chart title, about chart, I go here, equal to, and if I'm going to change this one to 100, it would be 0.5. If I'm going to change it to 150, it would be 0.98. So we also have this probability. Now suppose this is the demand for a product, and I want to make sure that my service level is 95%. It means I have enough product to ensure me with 95% probability, 95% probability, I can serve the customer. I can serve the demand. I will not be out of stock. And therefore, with probability of 1 minus this, I will be out of stock. And we call this risk. So there is 5% risk that we are out of stock, but 95% probability that we can serve the demand. Equal to norm. This time I click on norm inverse. Norm inverse, it tells me what is the probability you want? This probability. What is your average? This one. What is your standard deviation? This one. In those situations when we are not going to copy it down, we really don't need to log average and standard deviation. And then here, I don't have 0 and 1, I just enter this. So if I have this much inventory, with 95% probability I can serve customer, and there is 5% probability that I am out of stock. Now suppose I don't like 141.12, and suppose ordering 0.12 is not possible at all. I want to order either 140 or 145. If I order 140, then my service level is 95%. Let me multiply this by 100 and put it in terms of 100%. So 94.52%, that is my service level, and 1 minus that is probability of risk. If I have 145, then my service level goes up to 96.41 and risk comes down to below 4%. Now let me go here and again type equal to rand between, for example, 50 and 170, for example. Look, I get a number here. I get another number. I get another probability. I get another probability. Could you tell me what is the characteristic of the red area? What is the characteristic of the red area? What is the characteristic of the red area? The red area is between 0 and 1. And I have something in Excel called rand. Open parenthesis, close parenthesis, rand. And this gives you a number between 0 and 1. That is a probability. And we can use this number, which we have it in Excel, to produce normal random variables with any mean and any standard deviation. Let me copy this and place it here. So now each time that I click delete, a random variable between 0 and 1 is generated over there. Now let me go here and type equal to norm inverse. Norm inverse, this random variable and average and standard deviation. What is happening here? Look at here and let me know what is happening here each time. I push delete. 38, 70. What is happening each time? Look, each time a random variable from this distribution is generated. In the simulation part of this course, we need to generate random numbers from normal distribution, from uniform distribution, from exponential distribution. What I will do if I'm going to generate 1000 random variable from this distribution, I'll go here and type equal to norm inverse probability rand, give me average 100, now I need to lock it, F4, standard deviation 25, now I need to lock it, enter. This is a random variable from this distribution. These are random variables from this distribution. So if we want to generate random variable from a distribution, this is how we generate them. Later on in project management talk, in break-even analysis talk, and in many other talks, we need to generate random variables from different distributions, and for random normal variables, we use this technique. Let me go through a couple of other points to wrap up this talk. Now, suppose we want to find the probability between two numbers and we want to show it on the graph. I'll come here, 75, and here I define 125, and I want to draw curve for probability between these two numbers, and I want to compute those probabilities. So I'll come here, equal, and is this one greater than or equal to this one, comma, is this one less than or equal to this one. We need to lock this one, 4, and we need to lock this one because we are going to copy it down. Copy it down, false, 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 false. At some point, it should become true. Now we go here. If this is true, then we type this. And if it is not true, we put nothing. Click. Now I go here and I make a change. This is probability of less than or equal to 125. I have already logged average and standard deviation. Therefore, I copy this and I paste it here. That refers to 75, average and standard deviation. So this is probability of less than or equal to 125, and this is probability of less than or equal to 75. Then if I want to compute the probability between them, equal to this one minus this one, enter. Now let's see if we can fix this one. First of all, for round F3, we refer to this one, which is the probability of being between those two. And I need up to here our equation is working. Probability of 75, and this one I want to have this part right 2 and right of this one comma 2, and up to now we are fine. X greater than or equal to 75, and all I need to add is and left of this one comma 2 and 125. 25, and I will show you what difficulty we have. Here we have two x's. We need to remove one of these two x's, and let me show it to you how I'm going to remove it. We had left and 2. So I go here, I type right of this left and 2, comma, 1, enter. Oh, now it is fixed. And that probability is equal to this. Come here. Now let me go here, type rand between, say 30 and 90. Copy to the right. 100 and 170. Now we can find probability between every pair of numbers. We can show that probability on graph, and we can draw the graph, and we can also graphically show our answer. Just to end up our discussion, as I said, if we want to generate random numbers from this distribution, equal to norm inverse rand, because you want to randomly generate something between 0 and 1 as probability, average, and log it, standard deviation, and log it, enter, and copy it. I covered a lot of material here. The main idea is, if you think, if you didn't follow something, don't immediately say, oh, explanation was not clear. Just look over it, think, and you will find it out. Thank you very much. Bring your questions to class.